Welcome students. In this video, let us look at the topic of Rolle's theorem for polynomial functions. So the Rolle's theorem is a very important theorem in your calculus topic and which will be applicable for polynomial functions. So let us see what Rolle's theorem is and how it can be applied for polynomial functions. So Rolle's theorem states that if a function f of x defined in a comma b satisfies the following conditions. If a function f of x defined on closed a comma b satisfies the following conditions, which are f of x has to be continuous on closed a comma b. The second condition is f of x has to be differentiable on open a comma b. So if f of x is continuous on closed ab, f of x is differentiable on open ab. And the third condition is f of a is equal to f of b. If f of a is equal to f of b. So if these three conditions are valid, that means if you look at the graph of the function is defined from closed a to closed b. A and b are some given constants and the function has to be continuous in ab. That means the graph of the function should not break between a and b. F of x is differentiable on open ab. That means there should not be any sharpnesses. There should not be any sharp edges between a and b. And f of a has to be equal to f of b. That means f of a, if this is this point, f of b should also be exactly equal to f of a. Now a function has to be continuous and differentiable in this interval, f of a being equal to f of b. So let us draw a sample curve which looks like this. Okay, there can be many sample curves which go from this point to this point being continuous and differentiable. So now if the function satisfies these three conditions, Rolle's theorem says that there exists then, so if these conditions are valid, then there exists a C which belongs to open a comma b. There exists a C which belongs to open a b where f dash of c is equal to 0. That means there will be at least one point between a and b, strictly between a and b, where the value of the differentiation will be equal to 0. That means there will be at least one point c where the tangent is parallel to x-axis. The tangent is parallel to x-axis. There can be more than one point also. What this theorem states is there exists a c which is in between a and b where f dash of c is equal to 0. There can be more than one point also. Rolle's theorem says that there is at least one c which satisfies the condition f dash of c is equal to 0. So this condition can be applied for polynomial functions. This condition can be applied for polynomial functions because the polynomial functions satisfy the first two conditions. So the graphs of polynomial functions are always continuous, they don't break, and they are always differentiable. That is, they don't have sharp edges. You can take any polynomial function of any degree, they will always be continuous over all real numbers, they'll always be differentiable over all real numbers. So these two conditions are always valid for polynomial functions. So what does this theorem say for polynomial functions? If f of a is equal to f of b, if there are 2 points a and b such that f of a is equal to f of b, in between a and b, f dash, the value of f dash will be equal to 0 at least one point. So if f of a is equal to f of b, then f dash of x is equal to 0 has at least one solution in open a comma b. So for a polynomial function, these two conditions don't need to be specified again, because these two conditions will automatically be satisfied for polynomial functions. So if f of a is equal to f of b, then f dash of x is equal to 0 has at least one solution in open a comma b. So this is the Rolle's theorem for polynomial functions. So let us see how standard questions are asked in this topic.